Welcome to Study Loop.
So in this problem, we are given with a hypothetical reaction where A is reacting with 2B to give us 2C. We are given the value of the equilibrium constant in terms of molarity. We are given the number of moles of C which is present initially in the reaction. We are given the volume of the reaction vessel, and we are given the equilibrium concentration of A in terms of X. And in first part of this question, we have to find out the equilibrium concentration of B and C in terms of X. So, since we are not given the initial concentration of A and B, that means we can assume that we don't have any concentration of A and B initially, but we are given the number of moles of C at the initial point, which is 1 mole, and we know the volume of the reaction vessel. So, from these two values, we can find out the initial concentration of C. So initial concentration of C will be number of moles by volume, that means 1 mole over 1 liter, and from here we get 1 mole per liter or molar. So now we can set up an ice table to find out the equivalent concentration of B and C. So if we set up the ice table, A is reacting to B to give us to C. Now the initial concentration of A and B, we can assume 0, and the initial concentration of C is we have calculated as 1 molar or 1 mole per liter. Now the change, so the equilibrium concentration of A is given as X. That means the change in concentration of A will be plus X, and since in with one molecule of A we have two molecules of B reacting, that means the change in the concentration of B will be plus 2X, and in that case these are the product, the change will be opposite, and that means again one molecule of A can produce two molecules of C. That means if the change in case of A is plus X, in case of C it will be minus 2X. That means the equilibrium concentration of A is X, and the equilibrium concentration of B will be 2X, and the equilibrium concentration of 2C will be 1 minus 2X. So in terms of X, the equilibrium concentration of B is 2X, and equilibrium concentration of C is 1 minus 2X. This is our answer to the first question of the question A. Then in part B, we have to find out what limits must be placed on the value of X so that all concentrations are positive. So from here we can see that if we want positive concentration, that means from here we can see that X is the concentration of A, and the concentration of A to be positive, we have to write X is greater than 0. Now from this one, which is 1 minus 2X, and again also 2X will be greater than 0, and from the equilibrium concentration of C, which also need to be greater than 0 or positive, that means 1 minus 2X is also greater than 0. So from here we can write that 1 is greater than 2X, and from here we can write X is less than 1 over 2, that means X is less than 0.5. So from all these three values you can see that X must be greater than 0 and less than 0.5 for all the three concentrations to be greater than 0 to be positive. So if we write them all together, we can write it 0 is less than X is less than 0.5. So this is the limitation on the values of X for all the concentrations to be positive. Now, in part C of this question, we have to set up an equilibrium constant expression, and we have to derive an equation that can be solved for x. So now um, if we just put this equilibrium concentrations values in the equilibrium constant expression, which is Kc, as we know that the equilibrium constant value Kc is equal to the product concentration over the reactant concentration. So the product concentration will be, so it is concentration of C, and since he has a coefficient of 2, it will be go as power, and as the reactant we have A and B, also has another coefficient of 2, so this power will be also 2. Now if we just plug in the equilibrium concentration values, so the C's concentration is 1 minus 2x whole square, A's concentration is x, and B's concentration is 2x whole square. And now we know the value of Kc, which is given as 0.25. That means 0.25 is equal to 1 minus 2x whole square over 4x cubed. Now if you rearrange this equation, we will get a quadratic equation like, or we'll have a equation like x cubed minus 4x square plus 4x minus 1 equal to 0, which is a cubic quadratic equation, and this is the form of the equation which can be solved for x, and which we are asked for to find out in part C of this question. Now in part D, we have to um, assume, or we have to estimate the solution of x by plotting the cubic equation in the allowed range of x, which we have which we determined in part B. So the range of x is from 0 to 0.5. So if we plot this quadratic equation in this range, or if we solve this equation for the values of x at that range, so if x's value is 0, we'll find that y's value is minus 1, and if x's value is 0.5, y value will be 0.125. So now if we plot these 2 points in a graph, it will look like this. So from here you can see that um, so here is our y is equal to minus 1 value, or this is our point of 0 minus 1, and this is our point of um, 0.5 and 0.125. And if we find the value of y for a value of x equal to minus 0.5, we'll see that the value of y will be minus 0.425. So, no, the value of y will be minus 4.125. Minus 4.125. So that means another point is somewhere in this way here. So if we just add these 3 points, it will be a graph like this, which by which we are um, joining or connecting the points 0 and minus 1 and 0.5 and 0.125. And while we are joining these 2 points, we can see that this will intercept the x-axis somewhere at 0.4. So we can say that, and since in the question we are state that The point at which the cubic equation crosses the x-axis is the solution. So our solution of x we can estimate as 0.4. Now, um, in part E, from the plot in part D, we have to estimate the equilibrium concentration of A, B, and C. So now we know the value of x, so we have estimated the value of x from the graph, and now we can place this, plug in the values of x here in the equilibrium concentrations, and we can estimate the equilibrium concentration of A, B, C. So the equilibrium concentration of A is x, that means it will be 0.4. Equilibrium concentration of B is 2x, that means 2 times 0.4, it will be 0.8. So all are molar or mole per liter. And for C, it will be 1 minus 2x, that means 1 minus 0.8, or it will be 0.2 molar. So these are the estimated equilibrium concentration of A, B, and C based on the graph of the cubic equation we have found here.